Okay, warm welcome back, everyone, to session 7 of the 4th semester of Core Enaction at Mind and Life Europe. This is our final themed session of the semester, and so we're excited to end on a very high note with some wonderful guest speakers this evening. And so this evening will be focused on the verb computing. So computing differently, AI and robotics, and the future of cognitive science. So we'll be weaving our way in and out of those topics this evening. But before we get into the heart of it, I would just like to take a moment to introduce a co-host that we have with us for the first time this semester, who will be helping our usual host, Letitia Renaud. We're really honored to have Elena Kufari join us. Hi, Elena. Thank you so much. And I'd like to just introduce her before we get started with a grounding exercise and then the introductions of our two speakers. So some of you may know Elena's work through the book that she co-authored, Linguistic Bodies, with Hannah de Jager and Ezekiel Di Paolo. So Elena is assistant professor of psychology and scientific and philosophical studies of mind at Franklin and Marshall College in the United States, a philosopher of cognitive science with a background in phenomenology, pragmatism, feminist philosophy, and cognitive linguistics. She has co-authored and authored papers on the enactive approach to language, gesture, metaphor, and narrative pacing. She is, as I mentioned, co-author with Ezekiel Di Paolo and Hannah de Jager of Linguistic Bodies, The Continuity Between Life and Language, which was published in 2018, which elaborates participatory sense-making into an approach to our lives as linguistic beings. Recent work develops the ethical and political implications of the Linguistic Bodies framework, with studies on habit and hope in the face of the global climate crisis. And she's currently interested in interactions between linguistic bodies and other meaning-making agents, and in increasing participatory possibilities in technology and in research methods. So we're really glad to have your expertise with us, Elena, this evening. And of course, we're joined by our other wonderful co-host, Letitia Renaud. And before I pass the baton to you, Letitia, to introduce the two guests, as has become custom over the last several weeks, I'd just like to start with a really brief grounding exercise, just to sort of bring our minds and bodies, gather our minds and bodies back into the room, wherever you may be. So maybe if you'd like, just take a moment you can close your eyes, you can keep them open. Some people find it helpful to close their eyes for this. And knowing that this session will be focusing a great deal on the question of computing and AI, and to some extent robotics, maybe we can drop the question of sentience and the sensate body into our field of awareness, and just maybe consider for the next few moments what information, what experience we have of the sensate body. And by extension, what sorts of sensations are we aware of? Within the body, maybe interoception, proprioception, contact of the body with its environment. Maybe the interaction of the sensate body with its environment. And then when you're ready, maybe opening your eyes if they've been closed, and then coming back into interaction with what we all have before us, which is very much part of what we'll be talking about this evening, our computer screens to some degree. And I'm happy to hand it over to you, Elena and Letitia, to get us started for tonight.
Thanks so much, Johanna, for this exercise, for the introduction, and thanks, Elena, for being here with us tonight. It's a pleasure to have you here. So I would like to introduce our invited speakers. It's a pleasure to have today with us Luc Steels. So Luc is Professor Emeritus in Artificial Intelligence from the University of Brussels in Belgium. And he studied linguistics and philosophy at the University of Antwerp and computer science and artificial intelligence at MIT in the United States. He founded and directed the VUB Artificial Intelligence Laboratory in Brussels from 1983 at the Sony Computer Science Laboratory in Paris from 1996. From 2011, he was research professor at the Institute for Evolutionary Biology at the University Pompeu Fabra in Barcelona, Spain. Currently, he is scientific director at the Venice International University and senior strategy advisor at the areas at Barcelona Supercomputing Center. Steels worked in many areas of AI, from computational linguistics, expert systems, and knowledge representation to neural networks, cognitive robotics, and value-aware AI. He's primarily interested in using AI as a tool to investigate embodied mind, meaning, language, and consciousness. In 2022, Steels received the Distinguished Service Award of the European AI Research Association, the highest award for AI in Europe. He's currently chair for Natural Sciences of the Royal Flemish Academy for Science and Art in Belgium. Luc Steels has also been active in performing arts as a composer of operas and theater. His latest opera, Fausto, performed in Brussels and in Paris, was about transhumanism and the limits and dangers of using AI in attempts to gain immortality. So Luc, thanks very much for accepting our invitation and being with us tonight. And I will introduce our another invited speaker, Takashi Ikegami. So Takashi is a professor in the Department of General System Sciences at the University of Tokyo in Japan. And his works encompass both the arts and sciences and deal with complex systems and artificial life. He received his doctorate in physics from the University of Tokyo in 1989. His research is centered on complex systems and artificial life, a field that aims to build a possible form of life using computer simulations, chemical experiments, and robots. To bring to fruition the concepts developed through the study of artificial life, such as autonomy, enaction, sustainability, and evolvability, he has newly started several experimental and conceptual works using an android called Alter 3, a large-scale Boyd's model, and other biochemical experiments. He has also been involved in media art activities since 2005. So Takashi, thanks very much for being with us tonight and for accepting our invitation. Feel free to complete with any information that you find relevant. So to start our conversation, and before passing the floor to you, I'd just like to remind us all of the two guiding questions of this semester. So throughout the whole semester, we are talking about different verbs and using two guiding questions as a thread. And they are, so the first one is tell us something about your intersubjective expertise in your practice. So as you may have seen in the other sessions in this semester, the starting point of the participatory sense-making theory is that everyone has intersubjective expertise. We are all experts in that just by virtue of being humans. And I think that this will be especially interesting for this session, this expertise and this relationship, its relationship with humanity. So when each of you, on top of that, have a particular intersubjective expertise in your work as researchers, professors, academics, artists. So we would like to invite you to speak about your practices. In terms of intersubjective expertise, you already seen it, you know to be there in it, and as well as possible questions also about the intersubjective expertise in your daily practice. So what do you still wonder about in regard to the intersubjectivity? Is there opening to improve? Are there areas of friction, of quest, of what tension? So this is the first block of questions. And the second one, I know it's a lot, but the second question is, what is at stake for you as practitioners? This can be on the meta level, so at the level of the methodology, what is to do, for example, participatory research, or more directly in your practice. What matters to you? What is at stake for you as researchers, as professors, as artists, as you engage and interact with the students, with collaborators, with institutions, with machines? So this is the second block of questions, and this is just to start our conversation. So feel free to present your work and to add more questions to these ones. So thanks very much, and I will pass the floor.
Okay. Well, thanks so much for a nice introduction. And I briefly introduce what I'm doing now and what I have surprised recently. Okay. See. Okay. So you can see this video. So
Yeah.
So I have been making Android since 2016 and 17, and this is Android Ultra 3, and he has like 43 axes, so that we put the 43 air compressor in each angle, and then he has a camera in his eyes so that he can see the people in front of him, and at this moment, it was 2019 that he tries to imitate human behavior in front of him. So it goes like this. So when one of my postdocs, do this and that, then Android is going to imitate. Okay, but his imitation is not perfect, so that sometimes, I mean, quite often that he fails to imitate, right? So the audience, coming to in front of Android, tried to imitate Android, instead. So at the end, the imitation becomes successful. So this one is a bit cheating, but it's a cooperative mutual imitation game, sort of. But when I did this, there was a huge problem. Is that we don't understand what the author thinks. There's no communication. It's just a mimicking, right? It's just apes experiment, as it is saying. So I wasn't quite sure what to do, but then there's a large language model came out, which was a big revolutionary point. I think there are many people still very much against large language model, but to me, it was the second big scientific discovery since chaos for me, right? So the chaos is something that the simple dynamical systems can simulate chaotic behavior, right? That was already like 30 years ago. But now this large language model can show you very interesting things. Briefly speaking, what LLM can do is this model can propose a theory of meaning. So before LLM emerged, we don't have a theory of meaning, so that we cannot do any sort of sophisticated communication, sophisticated intelligent behavior or anything. However, after LLM came into the world, then we can deal with the theory of meaning, which is a very, very big thing, I think. So we decided to couple LLM with this Orta 3, okay? So as you may know that there's a prompt engineering, so we put the prompt into the LLM, then put into the hardware, which is Orta 3. But at this time, LLM, we use a ChatGPT 4V, means that we can put video into the prompt, which is very very big difference, because now the ChatGPT can see the world with his own camera, right? Then he does this, he does the other thing, right? So but before the video input was possible since, I don't know, maybe since the last December or something, right? Before that, we are not using the video and then just put the text prompt. So something like this, your task is to describe exaggerated emotional expressions that accompany the content of a conversation and blah, 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 this kind of things, right? And then there's the text. So like drink some tea, then you have to generate 10 successive sentences to, associated with this text. Then the second prompt is to get to successfully reading those sentences created by the prompt 1. Then the prompt 2 is creating a Python code for controlling the Orta 3. So that's 2 prompts. One, first of all, we just gave a text, and then the prompt 1 is decomposed into like 10 sentences, and give it to prompt 2, then prompt 2 translate them into Python code. So let me show you how it works. So this is when I say pretend the ghost, is what I said to him. So I don't know whether this is a European ghost or a Japanese ghost, but anyway, so he does pretend the ghost, right? There are many things that he can do, but we don't have to tell the details how he moves. But I just tell him, what to do with this. Okay, and the next one is play the electric guitar. Okay, can you see me now? Yeah. Okay. So this kind of behavior is almost impossible without using ChatGPT. So I was really surprised. And this one was more like a gesture, but also we can do like this. This one is it's more like a declarative sentence. Like I was enjoying a movie while eating popcorn at the theater, when I realized that I was actually eating the popcorn of the person next to me. That was the text given to him. Then so why don't you just play the one that was given by the text, so that he does. So the point is, I didn't give any sort of the details, but I just told him, pretend the ghost, or enjoying the movie and eating the popcorns, and that's the only text that he interpret how to behave according to that. And then the scenery from the camera is like this. So this is his hands, and this is the room that he sees. So, but I was a bit still dissatisfied because this is not his spontaneous movement, right? There's no, it's still a little bit of autonomy, right? But mostly he is just mimicking. He was just pretending what was written in the prompt. So next time I told him that you can, because we can use prompt B, so that what do you see in your eyes, and then do whatever you want. That's what I said to him. But this is the first time that I said to him without giving any command, but just you can do whatever you want to do. Then what he says is like this is very close to what the first one, and that's the prompt. That's the text that he said to us. But he said, "Well, the room is so messy, so I want to clean up." That's what he said. So I was so surprised because the room is messy, is already there's a meaning in it. So the Android gave the meaning, attributed the meaning to the environment. Then, depending on that, he decided he wants to clean up. He doesn't have to clean up, right? That's his decision that he wants to change the environment, the images, right? So you can call it affordance, or you can call it some other words, but I won't call it sense making, because it came from the gigantic database. It was acquired by the LLM, and then after that I was discussing with my graduate student, and then Otto says, "Hey, so I want to be the member. I want to discuss with you guys." That's what he said, and he cannot move, but he tried to come close to us. So it was my first time that I felt a bit afraid, because he wants to come to discuss with us, even though he cannot walk, right? So he does like this. So he's crawling, and then wanted to discuss with us because he thought he was a friend of us. So this one is like we just standing there and chatting each other, but there's no meaning in it. But he said he thought, Orta thought that we are discussing something quite important, and he wants to be the member, and that is his spontaneous decision making. So this is very different from this the previous Android or whatever the other robot is doing. And because this one is something like what I call sense making in generating autonomous behavior. In this case, is that it is essential to assess and attribute the value to the inputs that all the Android receives from its environment, right? Then, if the room is messy with cables, then Orta, should I want to clean up? So we believe that this process of valuing its environment pertains to the matter of qualia, or you can call it sense making or participatory sense making, which came from the LLM. So that's based on this recent discovery. I want to discuss with Luke about whether how close this sense making is to human beings, and I think it's I think this is pretty much big progress in experimenting Android Orta 3. Thank you so much.
Thank you very much, Tadagashi. It's really very intriguing experiments and very intriguing questions. So I will pass the floor to Luke.
Yeah,
I'm curious
okay.
to.
Yeah, so we have to make this the seminar a bit exciting. So I will be a bit skeptical about this experiment, and then we can, in a friendly way, of course, um, because you're using words like wanting, I mean, sort of humanistic words to describe what is going on here. And indeed, this is a way you can look at this, and but very well that I mean, you understand very well how these large language models work, right?
Yes.
And basically, it is based on a huge set of data, which statistical model is being extracted. And so in the case of language, for example, it is really about which words can occur together. And
Yeah.
so for each word, then if this particular word occurs in the context, then the likelihood of that word is high or low. And so it's basically uh, pasting together these stretches of sentences or phrases. So in the case of images, it's an associative network, right?
Right.
Between images and then captions of those images that co-occurred with this in the training data. Now, so then the behavior that we see, I mean, intuitively, well, at least that's what I think, is that we do different things compared to that. And so if we take this viewpoint also of enaction and so on, is that the categories that are used have to do with relevance. Okay, if something is relevant, like in the case of color, for example, between red and green, there are distinctions that are relevant in the interaction between the agent and the environment. And so this kind of information is not available in the data, the test data. I mean, you could say that the categories, so it does build categories, but the categories have to do with prediction, predictive power. Or if it's unsupervised learning, it can be clustering algorithms of some sort. So there is a difference between statistical regularity and relevance to something, because I mean, we talk about a red and a green traffic light, but I guess in Japan the traffic lights, they look more bluish. Maybe you didn't notice. I noticed it when I was there, and this has to do
Okay.
also with the name of I forgot the name for blue in Japanese, but so what is important is the distinction and not the exact data, right? And a category can be very different in one language compared to another language, and things like that. So I think in these systems, the ChatGPT and other systems, I would very much hesitate to ascribe to them uh, some of like sense making. Sense has to do with relevance, right? It's a distinction that we make because they are relevant, and then participatory sense making because they are relevant. We co-construct these distinctions because they are relevant for both of us in particular contexts and things like that. So I'm a little bit well. I think it's great that you do these experiments and that we figure out, all sorts of things that you can do, because it is amazing that with this particular mechanism, the statistical pasting together of fragments and so on, that you get the results that that you're showing. So I'm not saying it's not useful, or I'm not saying it's not it doesn't work or something like that. There is something to it, and I think also biological minds exploit this kind of something like this mechanism.
Mm-hmm.
But I would be more hesitant to ascribe subjectivity, for example, or intersubjectivity to this kind of interaction.
Mm-hmm. I see. So is it okay that we can continue this? Okay.
Please.
Oh, thank you so much, Ruth. Yeah. Well, yes. For the moment, I don't think every this is very much similar to what we do, but my claim is I think there is two claims that I want to make here. The first one is that LLM or ChatGPT is not just a collection of words, but it contains social norms, social rules. What is bad, what is good, and infinite amount of context and decision making associated with it. And here, that I think so. This is what we call the third person point of view, because it's not single person's point of view, but the third person's point of view. And this third person is always, for the long time looking at the human society. Then he understands what is the context and what people do in this context, right? Then Ulta is sort of talking with this guy and then made a decision, does some behavior, taking some kind of action. But this is actually what I thought, Ezekiel Di Paolo and Hannah wrote about participatory sense making. So once the android is going to the society, and he has to understand the social norms and social rules. But of course, one way is try to bring about him like a human child, for like 10 years or something. But this android has to be adult instantly. And then whether it's possible or not, then the easiest way is to couple with LLM, so that LLM gave him third person the point of view, in terms of Hannah's paper. So I think this is a very different developmental pathway, but he actually is like a human adult, living in the human society. That's my sort of understanding. And that's the first claim. And the second claim is, I think when we make a decision or when we take a action, the things we are doing is like the same thing. Like, parents told me, because I went to the school, that people, the friends and teacher, told me, I somehow I remember it, remember them and accumulate it in the brain, that finally make me decide in this way or other way in each context. So I don't see there are that many differences. I think the only differences is like, but honestly speaking, I don't see any big differences. So now that what author is doing is quite similar to what human does in each context. Maybe, other sensory, like touching sensors or haptic sensors, that might, add some information to it, which cannot easily describe with text. However, the essence is not so different. It's something that I'm thinking.
Yeah, well, I don't want to be the only one speaking here, but I think there is actually a big difference on many levels. So one difference, for example, the work of Kahneman, right? Daniel Kahneman, distinction between system 1 and system 2. And so system 1 is like fast responses based on past experiences, whereas system 2 is more making a model, doing reasoning, and things like that. Now, I think if we look at ChatGPT, then I would say this is a system 1 type of system. And so, based on patterns of interactions in the past, or based on well, data of all sorts, it learns how it observed in its data, it observes statistical patterns, and it is replaying them. But so there's the whole question about this system 2 capability. And there, instead of statistical induction, there's a lot more of construction, like social norms, for example. Whether you stop for a red light is not a statistical thing. It's a constructed norm, and we agree about it. And I only need to tell you once, right? It's not that you to start looking at patterns of people stopping before red lights, because if you do that now and then, somebody does not stop for a red light. So there are different types of knowledge, well, and already between system 1 and system 2. So I think, to me, this whole the sort of neural whether it's with reinforcement learning or deep learning, is a very behaviorist way of looking at the human mind, or at animal mind. I mean, it's stimulus response, and it's learned by reinforcement and things like that. And there's a whole cognitive approaches, cognitive semantics, etc., which I think we should not forget. And this is the big debate also within AI, the two, whether you actually need symbolic representations, you need symbolic images, or whether you don't need any of this, and just the sort of ChatGPT style deep learning is enough. So I don't know. I mean, I have to say to the audience who is not in this field, there are big debates going on inside the field about, I mean, with a kind of passion that is normally observed in football teams, when people are on one team or another team, and things get passionate.
But
Yeah.
can I say one thing? Because actually, I didn't, train this Android. We just gave him once. So this is a sort of zero learning. Everything is in LLM. So, well, and then also then you say that it's a first class, in terms of, of Daniel Kahneman's system 1, right? But whether there's a system 1 and system 2 distinction that exists or not is also a bit problematic, right? And then, almost all these animal, experiments and people discussing with neuroscientists is they just, try to understand whether the response has a lot of time or not, right? Well, if you really want to understand whether there's a reasoning responses and reflective response exists, then what I think you can do it is whether this brain can access to the memory or can respond in a very short time scale, or either one, I think. But if this is the most scary thing, if we ask Android, why you did this? Why you do that? That we always can ask him, right? And then he has always big reason for why he did that and why he didn't do that. So that's, well, of course you can say, well, he's always telling a lie, or it's a hallucination. However, this reasoning is sometimes very reasonable, literally. So, I mean, sometimes of course, he says, quite, out of context things, but basically his behavior and his excuse is very reasonable. That's why I was a bit surprised. And then I think the early AI strategy was always think about in the brain. That's why the reasoning becomes. But as you said, now that the emotion or feeling becomes more prominent, and then Orta 3's engine is not the reasoning. It's more about the correlation, more about the emotional feelings. So, well, we can test with a psychological experiment, test with a Android, and then we can classify them. Sometimes he has this emotional state, and then go to another emotional state. So controlling by the prompt, it's more important that the emotional expressions and then diversity in the emotional expression is the engine for the author to make a behavior and then making decisions. So I think rather than reasoning, he can, decide and choose the action behavior. So I think that's why I thought this one is pretty much different from the previous AI approaches, but it's more about, how the emotion is actually and practically making this, let order to make a decision. And then I think also in the context of society. So
But
yeah,
but
maybe.
here,
Yeah.
no, but here again,
Please.
no, it's like emotion, for example. Okay, I mean,
Yeah.
it's not because this Android says I feel sad that
Mhm.
there's any real emotion, right? I mean, emotions have to do with in our case, with the state of our body and the hormonal system and all these interactions between cognitive and emotional, but particularly with this hormonal system. And of course, in language, we can say, well, if somebody is sad, then maybe this person will, uh, I don't know, will look depressed or something like this. So yes, all these associations can be reproduced based on statistical criteria, but this is very different from really having the emotions, or laughing, for example. We laugh with our
No,
body, right?
yeah,
It's
of course,
something.
I totally agree with you. Yes, but what I think is, the most of the database that the LLM has learned from the internet is more about emotions. I think humans is not reasonable species. It's always emotional. It's always get angry, get mad, and get happy. Crying, laughing. So many of the sentences is always the context of emotions. That's why the author is always say, "I'm happy," or this is. Then of course it's also possible that I tested with scenery. That do you think which one is sad and which one is happy scenery? And then of course he can do it. So it seems to me he 100% understands which one is a happy context and which one is sad context. And I think what you are saying is that, well, of course, emotion is controlled by the hormones and other tensions within the human body, and then brain. First S1 and S2 has to be activated, so on and on. I agree, totally agree with you. However, of course, this is artificial life, right? They don't have any blood vessels, they don't have any hormones, or they don't have slow chemical reactions, but maybe he can imitate emotional states in a very different ways. So I don't think physical components cannot be the reason that he cannot have the emotional state.
Can I jump
Yeah.
in for a second? Since we are somewhat abandoning the model for discussion, but I do want to also signal as co-host that Luke Steele should have a presentation
Yeah.
turn when we feel that it comes to this. I want to stay for a second, Takashi, and this is only slightly touching on the very active chat happenings, that you're raising a question of the possibility. I'm going to put aside the question of the sentience and the ontology of the machine for a second and just focus on the participatory possibilities. What really struck me is that you have style and genre in the movement manner because of the way you're, I guess, scripting from ChatGPT, like the acting embarrassed, the completion of these patterns. So it's almost like we're not getting linguistic norms like how to say, oh, I'm happy in this context, but actually now we're getting norms of behavior at the level of style and manner of movement, which was really interesting. And then what I wonder is, how does that translate back? Because how does that, change the relationships with the humans or the linguistic bodies in the space with the robot? And I'm wondering if you've tried having humans who are not aware of the prompts tell you, oh, the robot was eating popcorn and then was embarrassed because he was eating the wrong popcorn. Like, is it intelligible if we don't know the prompt? Can it enable that kind of connection across? Because I hear you saying there's like an asymmetry. Yes, it's learning, it's like a child, but it can participate in our norms because it's observed enough of them and it's actually embodying them, which is kind of just really fascinating. So for the sake of argument, I'm curious about that. Like, do you think that it's doing a good enough job that now it will make a dynamic grow between itself and a human? Like you showed us some really cool things, but not an interaction per se. So that's what I'm kind of curious to hear you talk about a little bit more.
Well, so I come from a second question. So right now, our experiment is whether the author has a sense of self or not. So like Sean Gallagher said, that we should test with a sense of agency and a sense of ownership, whether he has it or not. And it looks like, for example, like we put the mirror in front of him, and then there's his image is on the mirror, right? And then I think the prompt was something like test whether you're on the mirror or not. Then he raised his hand or does this or move like this way, and then he said, "It looks like I can control the robot on the mirror." That's what he said. So because the movement, what he does, he wanted to move, and then the movement on the mirror is the same, is synchronized. That's what he thought. He was controlling the robot, which you can see on the mirror, but he couldn't understand that that's himself. And that was very difficult. So agency is fine, sense of agency is fine, but self-agency or self is very difficult. And the second experiment that I did was like put the knife in front of him, right? And what he did was, he did this. So it was scary, right? So he removed his hand. Then we asked him, why did you did this? And he said the way that the knife was against me and it was a little scary. That's what he did. He was so dangerous. That's what he did. But once you put the knife in a different directions, and his answer was quite different. He took it as a tool. So okay, so somebody is moving a knife, and he take as a tool. But once the knife is against him, and then very close to him, and then he began to say, "Oh, it's scary." So that's what he tried to escape from it. Means that there is some sort of sense of ownership exists. So, but still, he doesn't have the sense of self. So the self is something that we are missing something. That's why we put so many sensors on the surface of the skin of the Android right now. And then when he touches by himself, then maybe because it's a sensing of reception and sensing of action is happening at the same time, and if he notices it, he would say that, okay, there's something going on, and we expect that he can understand what's the self, I guess. So that's what. So and then also this is pretty much like a embodiment, right? The self, the body is necessary for him to get the sense of self. So that's I thought was interesting. What was the first question was?
But a sense of self also comes from, in tiny humans, from parents.
Yeah.
from
Yeah.
others. So I wanted to hear more
Yes.
about his interactions and what kind of dynamic.
Yeah, well, so this is entirely his own conflict in his own brain, because as I said, LLM has self-organizing third person, which I think it's what Hannah was saying, right? This third person is, looking from the very somewhere somewhere in the ceiling, that is observing all how the humans behaving each other. That's what he learned from the third person, not directly interacting with the other person. So that's, I think, it's the interesting part. That's why this participatory sense making is coming into play with, not just the direct, sense making things.
Thank you, Takashi. We have a lot of very intriguing and interesting questions in the chat. So before the break, I just would like to invite Luc to talk
Yes,
about
yes, of course, yes.
his work, because I'm curious, actually, because if I understood correctly, Luc, you are working with AI, even having this critical regard. So I would like to know more about your work and to understand how the AI can be in a sort of coupling with the humans, even if they are not, in your view, having the human characteristics.
Yeah, okay. So let me also share the screen. I will try to be brief. Let's see. Okay, I also have a few slides here. Oops. Well, so indeed, I've been doing AI research for a very long time, from 1974, in fact. And but the thing which is most relevant, I think, to the whole discussion on enaction and participatory sense making is experiments that I did 20 years ago, very much influenced by Wittgenstein, in fact, the idea of a language game. And maybe this relates also to the idea of linguistic bodies in some way. And so as you could see, it is also with small humanoid robots. These are the Sony Curio robots. And basically what I was interested in is how they can self-organize symbolic systems. That means language, words or phrases, grammatical phrases. And of course, these words and phrases, they express certain categorizations, certain conceptualizations of reality. So the question is, where do these conceptualizations come from? And how does the language to express them or to understand them, where does it come from? And so we set up many experiments, actually, with more than one robot always. But this is where the participatory aspect comes into account. So it's always about interactions between robots in a concrete environment. They are embodied, they are situated in that environment, and then they play language games. And the games are, for example, about drawing attention to a certain object in the scene, like in this case, a set of blocks of a particular color or whatever. And so I think these were actually also experiments in sense making, because these robots had to come up with categorizations of the world in order to achieve certain communicative goals. So the categories had to be relevant to the tasks they were involved in, and also the language also had to work then within the contexts in which these robots were operating. And so I'm not going to go into all the details, but this is a sort of alternative paradigm compared to the statistical induction paradigm that's underlying large language models. Of course, with this kind of thing, you cannot do what you can do with ChatGPT because it's always in specific history of interactions between different robots. So it is a totally different kind of application. And actually, these experiments were more to understand better what is meant by sense making and aspect change. This is another Wittgensteinian idea that um, how you look at something you could do it from different perspectives, and words and meanings dynamically change over time. So it was very much a complex adaptive systems point of view of language. So, oops. I don't know. In the interest of time, I think I will, this is another one where actually the human then is part of the interaction. Well, this human is me. Other experiments also a lot with mirrors, that robots look at themselves in a mirror and then get the sensory motor streams from which they then have to do categorization and have to evolve a language so that they can ask each other to do certain movements. Also imitation games, like Takashi was showing. But here in an imitation game, it's also the question, what is relevant to the imitation, right? If I say raise your hand, it can be like this or this or some other. I mean, and the way these categorizations are coordinated is often through language. So language is a very important part, I believe, of for us in any case, and that's also why we try to bring this into these humanoid experiments, is the vehicle by which we can coordinate how we categorize the world, and how this aspect change can be implemented. So I think I'll stop here. There's of course a lot to say, and but I think this is also to say that not all of AI is about statistical machine learning with deep learning or something like that. I mean, AI is a much richer field with many different approaches. Some of them are very logic based, others are inspired by cognitive semantics. The LLMs are inspired by distributional semantics and distributional syntax, actually. So what is interesting from a cognitive science point of view is the differences, the different approaches that are taken. And actually, any kind of approach that you want to take in cognitive science, if you can operationalize, you can define your theory sufficiently and operationalize, then you can, use it, or you could use AI to test your theory and to see how far it carries. So AI is much more neutral with respect to the theory that you might want to have. I mean, it's a way to build new theories, just like artificial life. You build theories about the origins of life, and you really build it experimentally to see whether your theory holds water, so to speak. And it's the same thing here. If you have a theory of the origins of words and meanings, I mean, then you can operationalize and you can try in artificial experiments to see what your theory is and how far it can carry. Okay, let me stop. Yeah, this is another, I think, can you still hear me?
Yes. Yes, yes.
It's a bit noisy, but the earlier on it was about the self. And so this was another experiment that we did about, some sort of notion of self, how that might arise by looking at yourself or looking at yourself in a mirror, or by other people looking at you and describing your movements, you know, and saying this is you making those movements. Yeah, okay, I'll stop. I'll stop here.
Mhm. So, can I ask one question? You know, it's just a quick question.
Yes.
So I think to me, it's the big the function of a language is you tell a lie, right? So hallucination is a big mystery, and then also I think it's quite interesting. So I was wondering, you know, but hallucination is a source of creativity. Of course, that's what the people are discussing. It's you know, a good part and bad part. It's the two different sides of the same coin, right? So look, have you ever, you know, observed or you know, tried to program those robots telling lie to each other, or you know, deceiving others, or teasing
Yeah, yeah.
others, or
There
something?
was one experiment actually. You see, in order to lie, you must agree about the language that you're using, and you to use the language in the proper way. Otherwise, you cannot lie. And so so there is a difference between creating a language system and agreeing on the meanings of words. Um, and there you have to have honest communication. And so we did experiments to see if in a population, if if the agents are uh, if they are using the words in the wrong way. So they want to say they want to designate a certain color like red, but instead they say blue. You know, even though they know that the word it should be red. Okay. Now, if you have the whole population doing it, your language is not coming off the ground. I mean, you need a high level of honesty in the use of language. And then when you have that, then you can lie. But if you don't have that, you cannot lie. And so we did experiments on that, but not on the lying once you have your system.
Well, I see. That's very interesting. But actually, so the other experiment that we did was each agent in a computer program has a LLM inside, right? Then they let them, you know, move around in a space, or you know, solve kind of program like you know, AlphaLord bar program or a prisoner's dilemma game. And then outcome is very surprising because people start to make a tag, hashtag, and then try to make a social network to discuss with each other. Or maybe sometimes, you know, it's a hallucination that they say, okay, here's the mountain that we should get there first. But of course, there's no mountain because it's a flat space. But that's they create and they try to get together over there, which is completely spontaneous. So my feeling is that, you know, the function of language, which is creating an existing, you know, something in the world, and then they talking about this, you know, non-existing something with each other. That's, I think, is very much like a language, like to me. And then, you know, like a game theory that people are usually using, like a finite number of moves, and then with the payoff matrix, which was very much disappointing to me when I was a student doing this. But now you don't have to prepare payoff matrix, so you don't have to prepare any bounded moves. Those agents can create the movement and then reward spontaneously, right? So the spontaneity is, I think, it's one of the most important thing in artificial life. So we are always, you know, care about why the spontaneous movement emerges from where, and why this spontaneity emerges. And usually, almost all the robot doesn't have any spontaneity, right? They do randomly move around, or you know, they just, you know, flip the coin inside the robot to discuss where to go, right? But we don't call it spontaneity, right? It has to make a meaning, which is, that's why that we do care about sense making processes. So the sense making is the king, and then it's the first principle that we have to think about when we make a robot. especially the social, participatory sense making is something that I think is one of the guiding principles when we design a robot. So that's why I'm always care about the hallucination, telling a lie, or making something that doesn't exist in the world, but still they can talk about it, which is I want to call it like a conceptualization. Is something like that people create the concept which wasn't exist beforehand, and that's still it's possible with this simple chat GPT 3.5 or Llama 2 or so I think well, that's why I think this is very much a revolutionary era that not just deep learning was just a tool, but LLM is not a tool. It's agent. You can interact with this agent, and so that's the huge difference between deep learning or just a gigantic network with a recurrent loop. But now you can discuss and talk. Well,
Can
yeah,
I
but that's
ask,
something. Yeah, sure. Yeah.
I'd love to ask the presenters a question before
Yeah.
the break on following up on Takashi's connection to participatory sense-making principles. So I want to say there's more in a participatory sense-making moment than just the interactors and just the interactors understanding each other, which is already like a huge feat in where you're working, right? And with artificial life. But and then I know the chat over here is very skeptical that there's actually understanding each other going on, and I hope we can get to some of that too. But I want to ask you for a second about the messiness and the extraness, like the excesses that happen when people communicate. So we have like misunderstandings, misconceptions. You started pointing to this with the idea of lies and imagination, but also just that, humans have incorporated so many different voices and possibilities. So when we're having a conversation, I could be doubting what I'm saying right now, or I could be remembering something else that I'm supposed to be doing, right? There's a sort of cacophony going on, and some of that will make me do something that maybe I don't intend to do, and maybe that will make you do something back that you don't intend to do, and we can kind of get this spin going that's beyond our intentions. And so it's beyond what we can program, it's beyond what we can anticipate, and it has expressive elements, and then the paths not taken. So my very rudimentary understanding of like algorithmic executive procedures is that a decision gets made and then that's it. Now we're here. The road has forked here, right? It's always a binary decision. That
well, but that's exactly what Luke explained about ChatGPT. The ChatGPT is just a probabilistic inference that he's doing, right? So that sometimes the what we call prior distribution is getting flat and flat. So even though he pick up this word for speaking out, but the next one is also more probable if the prior is very flat. But sometimes it's very much like a delta function. I mean, there's only one, candidate is high probable comparing with the other. Then of course it's something always there's no fluctuation to choose this one. So the usual context is fluctuating in between this delta function and flat distributions. So that we do. LLM is using algorithm, which is called transformers, but it's a very much like a stochastic machine. And then it's fair to call it, probabilistic inference machine, right? And this is not a big difference from like 50 years ago, right? It's just, making, random network. But what it practically doing is just a stochastic inference. But what I was going to say when I look about, I asked Luke about hallucination is that Ota himself seems like suppressing hallucination because of the embodiment. I don't know. When we do it, computer simulation, there are a bunch of hallucination that came out, and let the 6 agents talking to each other, right? And then of course we can do it at the prompt that we say the first one is a physicist, at the age of 50, and then he's a very cynical guy. And then second one is the artist, age 21, and she's conceptual artist. We can do it, right? And then put so many things, and then let them talk something, and then they talk very interesting, right? And then that's why we can write a script for the opera, and then we can write a novel. Very, very, there are no problem for doing this. So that's why I think, like what Elena says about like embarrassment or, like a metacognition things. Of course, that's possible. And then you cannot, the point is you cannot distinguish between the metacognition that we have and the metacognition that what he says that he was wondering what to do in the previous time. So I think it's all about Turing test. But Turing test, he almost passing, and some article says that it's already passed the Turing test, but honestly, I think it is 60-80%. It's few percent more to test pass the Turing test. It's almost there. That's what I think is the official announcement.
Can your robot systems regret choices that they didn't make? Can they?
Oh, that's a very interesting point, and I love it. The big difficulty is if I ask him, do you regret? And sometimes he said, oh, I'm very much regretting that, or something like that. But yeah, I think it's quite a dangerous point is that OpenAI reported last 5 days ago, 4 days ago, that the ChatGPT was made in order to cooperate with human beings and then try not to say bad things to human users. Therefore, I don't know what he's going to do, right? Those constraints is something that is always the big disturbances, right? Because the OpenAI try to control everything. So it's the behavior is very different from comparing with the last year, right? So that we try to think about using like a Llama. We're using like Llama 2 13B. 13B means that 13 billion parameter set. However, this intelligence level of Llama 2 with 13B is at most like a ChatGPT 3.5. So I don't know whether we should switch to Llama 2 or not. It's a kind of technical problem, but that's what I'm thinking. But there's one thing that I have to say. So I was working with Rook when he was in Paris. I visit him in Paris in 1998. That's where I came to interested in robots and arts and all this kind of stuff. So before that, I was just doing complex systems sciences and simulating equations and all this kind of stuff. So yeah, so ask him. He's responsible for that.
Well, I do not apologize. But maybe I want to say something about the Turing test and all that. I mean, the Turing test is not a good test. It was from the beginning, people like me, for example, they said this is a joke, I mean, we are not judging biology based in how well biologists can make artificial plants that cannot be distinguished from real plants. And
Right.
This is something that philosophers talk a lot about, but and now this is not. And why is it not good? Because first of all, because people tend to see much more into the behavior of a machine than is really there, particularly with robots. So they see two cameras and they say the robot can see. I mean, the robot can see nothing, these are just two cameras with images coming in. We see with our mind, right? And not with our eyes, but you see it is very, we did a lot also this time at the beginning of artificial life with very small robots, that were doing following and recharging themselves. And people would come to the lab and say, this is a bad robot. He's pushing against other robots. You should take they came out. I mean,
Yeah.
or egoistic robot occupying the charging station. But of course, these robots, there's nothing like being bad but we have a tendency to see the behavior of these machines. We put meaning into them, actually.
Right.
Or
Right.
ChatGPT, we interpret what is coming out in terms of he understands or he believes that or he wants this, but it's our and that's why the Turing test is very deceptive because from a scientific point of view, this is not a very good goal for AI or for the study of mind or anything like that. And I would say there's a lot of emphasis, and this deception is really dangerous because people then see a lot more, or like
I see.
now they write their papers and they let their papers come out of ChatGPT and then they hand it in, thinking that this is a serious paper with serious references, and then it turns out all these references are hallucinated, and there's all sorts of factual errors in it. So I just wanted to put that this is related to the question, what is it to engage in the world with AI, right? I think we should be much, much more careful and know much better, everybody, what is really going on so that we do not overinterpret or anthropomorphize, or how do you say that? The behavior of these.
Okay.
I see.
So yeah, thanks very much. The discussion, it's very lively, but I would like to invite everyone to a short break of 5 minutes. And then we will come back and to invite the participants to join us in the discussion. So I would like to ask the participants, if possible, during the break, try to, if they can, to try to synthesize, summarize some of the questions that are in the chat, so we can use our time after the break to discuss some of the things that are there, because there are so many interesting questions. So please try to summarize the questions, and then we can come back to discuss with
7:30 is fine, right? 7:30 is fine.
Half past, you're saying half past the hour. Yeah.
Yes. So welcome back, everyone. Now I would like to invite the participants to raise their hands if they have questions, but I already see a very good one here from Prashant. So I would like to invite Prashant maybe to ask his question on the video. If he would like to open his mic and just ask, or otherwise I can read the question.
Hello.
Hello.
Hi.
Hello, Prashant. Hi.
So my question was for Dr. Steels. He mentioned that AI is a broad empirical discipline where you can test different theories and see how they work. But I'm curious how he personally prioritizes what I'm calling phenomenological description, or kind of careful descriptive understanding of cognition. How do you put that in the context of different theories of AI, and how do you form a theory, or if at all you form theories informed by phenomenology or descriptive sciences?
You're still muted, Luke.
Yeah, okay. Yeah, indeed. So I want to reiterate, as you correctly saw, the point that AI can operationalize different theories of mind. And in some of the questions, I was reading the questions in the chat, somebody talked about development, for example. Well, I mean, there's a sub area in robotics which is called developmental robotics, where people actually do experiments in development. And so, when we say, can AI do this or that, or can an Android do this or that, then this is a vacuous question because it depends on what kind of theory you're investigating. Now, to come back to your question, the descriptive approach, I mean, it's difficult to operationalize because it's not a mechanistic theory of mind. I mean, AI is concerned with mechanisms. What are the mechanisms? And so various, like a lot of cognitive psychology and also like behaviorism or in linguistics, they propose mechanisms and the mechanisms can be tested. But if it's purely descriptive, then it is not really testable because it's not a theory about mechanisms. Maybe Takashi, do you have another idea on this?
Well, for the one, it's a difficult question. I think the people like Francisco Varela wanted to make a phenomenology to robot. That's why I think Prashant is asking this. So that's why I was trying to understand a sense of agency and sense of ownership first. Then after that, I think a phenomenology kind of consideration is probably we can work with it, and then we can make a theory. But at this stage, I think it's whether how far we can go with LLM is something that I'm working with. But I take Prashant's point that that's my original motivation to work with robots. So
Thank you.
Thank you, Prashant. So, João?
Are you listening to me? I'm not sure if I have good connection.
Yes, we can listen.
Okay. Few things that we are discussing in the chat that I would like to question. Because Takashi is proposing that this is a sense-making. Sense-making suppose autonomy. The idea that the two beings interacting doesn't lose its autonomy. So I would like to understand what could be the autonomy to a robot, the first question. The second question that has to do with Prashant's question is, to me, like I remember the hypothesis of Thomas Nagel about the bath, no? How if he has a different experience from us, we cannot describe what it is to be a bat. So what I was thinking when both of you were talking is, are we getting to a point that the experience of a robot, it's a radical different experience from being a human? Because if it's that so, what kind of symmetries is still possible to do between the robotic experience and the human experience? That was a question, because to me that could change some things, because maybe, okay, we cannot talk about emotion, but we should have to categorize this kind of complex predictions of robots. And I don't know if the development, for example, if the authorities is so radical of the experience of a robot could be used to understand human experience. So that was two questions that was revolving my mind when I was listening to both of you.
Takashi, do you want to start?
okay, yeah. Well, so quick answer to that question is that the autonomous robot is, to me, is he can motivate his own action by himself. Then the motivation is coming from the environment. So it's more like affordance, right? The affordance or umbrella is something that made robot to do something this or that, right? So, but this time environment is not in the real environment, but it's in his brain, which is called LLM. So once you have LLM with visual input, then you can break the symmetry, and then he can motivate his own action based on the meaning that he could attribute to the environment, which I think is very important. So the second question, I think Thomas Nigel is right, but I don't think we can carry memory once we became a bat or once we became a robot. So if the memory is transferable, then I think this kind of discussion is possible. But I don't think once we became a bat, then still we have a memory of when I was a human. Then I think the discussion will be different. Right? Once you become a robot, then it's just a robot, and then you have a totally different way of using memories and see the world. So that I don't think you cannot compare with your experiences becoming a robot and becoming a human. But still, we try to do a very similar kind of experiment with my Android. So once it gets something, then I can reply to you to the second question. Yes.
Yeah, I would say that these artificial systems, AI systems, life systems, we should view them as alien minds. Now, an octopus is also an alien mind.
Yeah.
And it does amazing things, and it does it in a very different way from us. I mean, there's almost no brain, right? It's a very distributed system, and it's using chemical processes in a much more sophisticated way, and so on. So we should view it as an alien mind, and then because like with ChatGPT, I mean, what Takashi is trying is to find out more about this alien mind, actually. What can it do, and how does it arrive at some conclusions or whatever? So this is one point. And then for the autonomy, I mean, there are many experiments in where these artificial robots, which are about autonomy. In fact, this was a very big topic in the 90s. But autonomy can be for many things, right? One of them is just for survival, to get energy to continue to exist, or to cooperate with others so that you have enough energy, or to defend yourself against predators of some sort, maybe that are trying to take your energy or whatever. And so there are quite a lot of there's a substantial literature in conferences like Simulation of Adaptive Behavior, Artificial Life conferences, which are all about autonomy and autonomy for basic functions like energy autonomy, but they can also be autonomy for learning. That what motivates you to keep learning, right? And so then you are autonomous, or we give the robots the autonomy to do actions so that they can learn by self-motivation, driven by curiosity. And so there are lots of papers actually in the literature that I think for psychologists or for cognitive science people have lots of ideas actually which have been explored already in artificial systems. So I probably stop here, because if we talk too much, we don't address many of the other fascinating questions that have come up. So I'll just stop here.
Thank you, João, for your question. So Ralph.
Yeah, thanks very much, both of you. It was a really interesting talks and debate, which is really what happened today, which I think is really interesting. I want to, before asking a question, I want to quote something very shortly from Elena's book. Now, sorry, Elena, but you don't mind this, where she says on page 33, sense-making is the capacity of an autonomous system to adaptively regulate its operation and its relation to the environment, depending on the virtual consequences for its own viability as a form of life. Being a sense maker implies an ongoing, often imperfect and variable, tuning to the world and readiness for action. Sense making naturalizes the concept of vital norms and lies at the core of every form of action, perception, emotion, and cognition, since in no instances of these is the basic structure of concern or caring ever absent. This is constitutively what distinguishes mental life from other material and relational processes. So my question to Takashi is, from where I'm looking, artificial systems, androids, don't have any concern or caring about their own existence or the existence of others, or even the existence of the world, for that matter. Yeah, and I wonder whether that isn't perhaps the most important difference. Now, how do you explain that caring and concern is another question, of course. I mean, I would look at things like aesthetic sensibilities, aesthetic in the original Aristotelian sense of a capacity to perceive the world in a sensitive manner, which involves emotions and other involvements, even a kind of visceral reaction to the world. You know, that knot in your stomach when you, at times, and things like that. And I wonder whether that's something that can never be programmed into a computer, unless, of course, we build computers from biological material. Then maybe it might be, or androids from biological material. Then maybe it might be possible to have these elements. But if it's not biological, I don't see how you can ever have that. That's my question to Takashi. And to Luke, when you mentioned Wittgenstein in relation to your robots, it seems to me that Wittgenstein was very interested, as you obviously know, in public criteria for distinguishing things. And it seems that those experiments were also looking very much at public criteria for the interaction between the robots. If I understood it correctly, maybe I didn't understand it correctly. But it seems to me that Wittgenstein exaggerated a bit when he rejected private criteria, not in relation to language, but in relation to things like pains and things like that. He was very adamant that private criteria don't matter. They fall out of the picture, like the beetle in the box, you know, in that famous experiment of his, thought experiment of his. And I wonder if that's true. I wonder if we don't have some kind of private criteria for mental states and mental processes, which he, for some reason, wasn't able to fully integrate into his way of thinking. I know this probably isn't very interesting to other people, but because I like Wittgenstein, I wanted to ask you that question. Thanks.
So can I answer first? Yeah. So so whether he also concerns self or the others or the world itself, we don't know that. So that's why I'm doing the experiment, right? But as I said, once you have a knife and then put the knife in front of him, then he tries to remove his hand. So well, you cannot say that that's why that he concerned himself. But once we don't know whether then humans can concern himself or not, because we do the same experiment and do the same behavior. So only the difference is because the human says, I'm so care about my body or something. Olga also says the same thing. He says that well, knife is quite dangerous, and I get injured. Well, that's something like that. So I think distinguishing a bit by saying whether he concerns self or the world or something it's quite difficult, and I don't think humans care about the world, right? I mean, they're just killing each other, and so I think Android is much better than humankind. That's my basic understanding. And then also the second question, that whether the biological pieces can be if we use the biological elements, then the Android can concern about the world or self. But that's something that I try to deny, right? But that's what artificial life is about. Artificial life is without using cell and DNA, still we can make living systems. So that's I call it replacement principle, which I call it, because usually there's a middle layer that below the middle layer of the spatial scale and temporal scale, you can replace with something else like electric circuit or computer program or anything, but keeping this above the middle layer the same, right? So that I think is the principle of artificial life. So we are challenging whether there is such a middle layer exists, or whether this kind of principle can be applicable to the artificial system, because of course everything is made out of molecules and atoms, right? But at a certain level, it's bifurcating into living systems and non-living systems. If we say this is true, then I think the biological system is an emergent phenomena of collective behaviors or large molecules or something. So that what I'm doing, besides experimenting order, is that I'm looking into the ants and honeybees, tetrahymena, all these living systems, and what kind of collective behavior that we can expect from them is something that I'm doing now. So, but I don't believe that a biological element is necessary to make a living systems. That's our basic principle for artificial life.
Yeah, so maybe I can say something. Well, first of all, to in the same line, indeed. Oh, can you hear me?
Yes.
Okay.
Yes.
No, I agree with Takashi actually that we are looking for this system level where just like in an ant colony where there's a path formation of the ants, without any supervision or hierarchical control or shared communication. I mean, they only communicate among themselves. And so these self-organizing properties are very important, I think, and I'm sure Takashi thinks the same way, for understanding intelligence also. And so also in the case of language, we're looking to understand these system properties that give rise of shared language systems and that can continue to change dynamically over time. But I wanted to come also to your question about Wittgenstein. Obviously, in the language game experiments that we have been doing, I mean, this does not reflect all of the properties or all the ideas that Wittgenstein, put forward, like as you pointed out, this idea of private versus public and all of that. What I wanted to emphasize is the fact of that language is constructed in a community by people together, and that the concepts underlying language is the way of conceptualizing the world is strongly related to your language, and so on. The many different aspects which I think resonate strongly with this idea of participatory sense making and enaction, and which went completely against this idea of the logical empiricist, point of view, or the ideas also of Chomskyan linguistics of it's all innate and this kind of thing. Instead of being dynamic, being adaptive, being all the time evolving, happening in shared contexts, and so that's what we try to translate these ideas into concrete experiments, robotic experiments.
Letitia,
Thanks.
okay. We have another person in the queue.
Yeah, we have Matthew. I would like to invite Matthew to ask his question.
Then maybe I can come back to the.
Yeah, please, just Matthew, please.
Okay, so hopefully I'm audible and no problems. My questions kind of vary, as the chat goes on. When I ask this question, it seemed a little bit more pertinent. It seems to be going back slightly to this question of phenomenology. But I guess I'll, within the literature, I'm curious about if there's any role to be played in the enactive approach in relying on the sense of phenomenology that Evan Thompson attempts to recover from Husserl as kind of like a inappropriate update, since the enactive mind was so very critical of Husserl, and as the authors say, the 2017 intro, inaccurate. So in particular, you have the development of the phenomenology over the course of an organism's own ontogeny. Then you have the development that occurs adaptively between organisms. And that's where participatory sense making plays a significant role. And then you have this idea of the phenomenology of like a culture or genetic that's able to be constitutive of, let's say, group sense making over time. Do those criteria of phenomenology play a significant role in constraining our attribution to sense making in the robotics case? Or should we just like kind of not think so critically about the role of phenomenology and its continental origins, to speak crudely? That's a question.
Well,
can I?
yes,
Please.
please.
Well, I don't know why the people stick to phenomenology. I don't. Well, if you like phenomenology and then applying to phenomenology, well, that's possible. But after you make a robot, right? But I don't think phenomenology is. I think phenomenology is useless before we are making a robot, right? Of course, you can always make a metaphor using phenomenology that there is a perpendicular intentionality that exists so that robot. Well, I don't think that's not the point that we are facing with. I'm not trying to be harsh, but usually that people say phenomenological things, but the question is something like whether the subjectivity exists in the robot. That more makes sense to me, and then I don't know whether the robot can have a subjectivity, but individualization of the agent is something that I'm very much interested in. And then that's also the problem of evolutionary processes and biological systems. Individualization versus, sort of diversification things. And that's something I try to understand with my robot and then also biological experiment.
One of the things I believe that is a real point of discussion is the role of representations. And well, maybe Elena can also intervene here because there's among a certain group a very clear statement about that representations are not needed in some sense, or that well, if I understand, Elena, your work with Anna is about to explain many things without representations. Now, from the viewpoint of computer science and robotics, this is difficult because there can be no computation without representation. I mean, you cannot add two numbers if the numbers are not represented somehow, and then you do an operation over them, right? And so also in these robots, I mean, it's full of representation, and this is what it's about actually. So this is maybe also a question where you can clarify things for us, because I sometimes think the word representation has different meanings in fields like phenomenology compared to the way we use it in computer science. And I don't know, maybe you could comment on that.
Well, Luke, what do you think of this, Rodney Brooks' idea of, intelligence without representation?
No, but he means, I mean, in his robots there are representations. When he made that
I see.
picture, this is what he meant is not for many tasks you don't have the symbolic representations, the descriptions in terms, of a scene in full detail. Well, not full detail, but in terms of abstract concepts. And so, like for wall following, you don't need this kind of representation. So he was not arguing about representations in general, because then he could do no computation at all, right? I mean, a representation is actually the medium in which the computation happens. Just like in chemistry, you have molecules. It's like saying in chemistry, we do chemistry without molecules. Well, what could that be, right? And so in computing, you always have this physical representation of whatever it is you are computing over. But so I think, yeah, there are
that's very nice. I see.
misunderstandings there, which I would appreciate, maybe Elena, that you could say something.
Sure.
Yeah,
I mean, I'm not going
Elena.
to fix any representational debates right in this moment for everybody. But yeah, I mean, and what I take from that paper that I teach in my mind machines and morals class, the Rodney Brooks paper that you mentioned, Takashi, is that you don't need something central taking in all of the layers, and that they can do things sort of in their own time together, right? So we don't need something decoding representations and getting meaning out of them in the way that some philosophers of mind thought about the mind as sort of like a theater that has to take in a representation of the world instead of working on it directly. So I agree, Luke, that there's many different notions of representation floating around. I'm working on co-editing a special issue that I wanted to shout out of Language Sciences, co-edited with Sebastian Laric, that's on, we're calling it Rerouting to an Open Future, on like participatory technology and becoming and languaging. And there are papers coming into that collection, so stay tuned for it, that are really making a case that a large language model isn't having anything to do with language, because if you understand language as a non-representational world involving fully embodied habit of linguistic beings, of situated meaning makers, that's just not what the LLMs are doing. They are, like you said, syntactic prediction models. So there's a lot at stake in the semantics of really defining what does it mean to represent, what does it mean to use language, what is language, and it's not clear that the ontologies are compatible, that a computational ontology is fully compatible with a linguistics body ontology. And yet we see some really fascinating things in what the robots in particular, the more embodied we get, the more social we get, and what they can do. And where my interest lies is sort of what we can do with them as sense makers, and what that changes about our own languaging, right? So we often language with babies, with animals, with machines, with things that don't language the way that we do, people with dementia, various things. All the time we're making sense with others, and that sense is partial, right? And yet it still matters, and it can matter differently to the different folks involved in that participatory sense making. So one thing I wanted to get back to on the earlier question about when Ralph read from the book about sense making, and Takashi said, well, humans don't care about the world, which I like totally hear, definitely hear that, is that care in this view is just non-neutral partial responsiveness, right? That it's not a view from nowhere, it's a situated perspective. And what I'm really fascinated by and worried by a little bit in the case of Alter 3 is that, yeah, we have an embodied place, like a perspective, like a real agent that pulls its arms away or sees itself in the mirror. But its brain, you say, is a large language model. Whose perspective is that? Like, that's sort of terrifying to me. That is like, whose cultures and perspectives are being embodied in that popcorn gesture and whose aren't, right? And whose interests are feeding the large language models. So there's a really fascinating tension for me in the ontology, the epistemology of Alter 3, because there's very local embodiment and like this hyper normed, massive scale brain that none of us have, right? So like what is care for that being is a really, I think, fascinating and important question. I'm sorry, like the mental representations thing, I dodged it a little bit to talk about care, but I think it comes back to this question of like, what is at stake in doing language? What is at stake in sense making? Can we get back to a place of partial perspective and not the view from everywhere or the view from Google?
Yeah, thank you. But exactly the large language model is sort of trying to make one big model for many different perspectives, which sometimes are in total contradiction with each other, right? Or ways of categorizing the world. I mean, if you know another language, it's not just the words are different, the categories are also different. And so if you push all that in a single model, then what is that model? I mean, you necessarily go to a kind of common point, so to speak, whereas there is in human language, in human culture, there's enormous diversity between people within the same language community, and certainly between language communities. So this is another problem I have with the large language model, is that this assumption of a sort of universal intelligence, which will cover everything independent of culture, language, personal history, but again, it doesn't need to be like that. You can build artificial intelligence which does have diversity, which does have historical, based on the experience of that particular agent. It's just that this particular experiment doesn't tries to make this kind of common. So it's more like a little bit like the search on the web, using Google, for example, is indexing a huge number of websites, millions and millions all over the world, right? And so the system like ChatGPT is also indexing in a way, in a different way, but it's indexing huge amounts of text and then putting it together, but losing the unique properties of each, because you make a statistical model, so you have to throw away the outliers and the well, of course, the outliers could still pop up because there's a kind of randomness in generation. That means it's not always giving you the best or the most probable, but you have this thing, a temperature, it's called, that you could change to get more or less close to the patterns, the statistical best pattern. And this is also how you get these hallucinations. But still, I mean, this fundamental assumption of a collective, of a unique collective general intelligence, so to speak, I think is problematic.
Well, just make a simple comment. Well, when we make like a 6 agents or 10 agents, and then each agent has a local memory. So if we want to make a unique individual, then it's possible. I mean, well, now that we have a bunch of local long memory that's possible for each agent. So of course, what you're saying is that, but the fundamental base model never changes, so that's what the universality that you think exists. But this is like a gigantic system, of course, right? And then we now have a bunch of different types of models came out like last week. Then each one has its own intelligence, I think, and then each one can scale up. I mean, scaling law that exists means that smaller one and the bigger one has much more intelligence than the smaller one. This kind of scale law exists for each, probably each LLM. So I think a diversity of LLM can be also possible within maybe this year. Well, yeah. So it's changing a lot. Yeah.
Yeah, unfortunately, we are approaching the end of the session and still have the impression that we have so much to discuss, but it's just a limitation of time. But I would like to say that it was a fascinating session, and we have a channel on Slack, and we can go on the discussion there, because there are still so many questions in the chat, and unfortunately we didn't have the time to discuss them all. But we have this channel there, so maybe we can still continue in this conversation, because I have the impression that it's so rich and we couldn't really explore everything. But it was a very rich, intriguing, fascinating. So thank you very much for being here with us tonight. Takashi, I know it's very late in Japan, so
yeah, 3 a.m. Yeah, so yes. I don't know whether I can,
so definitely it's late. So thank you very much.
Yeah, thank you very much. It was very nice, and I would continue this kind of discussion again. If there's opportunity to do this. Yeah, thank you so much.
Let's do that. Thank you. And thank you, Luke, also. And Elena, thank you very much for being with us too.
Thank you. Thank you so much to our presenters.
Thank you.
Yeah. Thank you, everyone.
Thank you, Luke.
And Luke.
Ciao, ciao.
Yeah.
So I think we have an S.
Yeah. Bye-bye.
It's at the end.
And Luke's, yeah, I hope see you soon.
Okay, I think we'll end there then. Thanks. We'll meet back here in 2 weeks, everyone. We'll take a break next week. And as our presenters were just saying, we can surely continue this conversation. So outside of the space on Slack and in other ways in the next few months, I'm sure. So thank you to everyone. Yeah. And on behalf of
and we will be posting the chat on Slack too.
Yes, and we can post the chat on Slack as well. Okay. So we'll see everyone soon, and thank you again to everyone for joining us.
Thank you.
Thank you so much. Bye-bye.
Good evening.
Bye-bye.